The second to last part of the FE exam focuses on basic electrical engineering. So they're not going to ask you a whole lot of questions on electricity, but there still will be a few. So you'll only get about 6 to 9 here, and this will cover the very basics. So like no current, no charge, no voltage, P equals IV and B equals IR, like that kind of stuff. Current and voltage laws, so be able to go around the circuit and figure out what is the voltage drop across the resistor, be able to find an equivalent circuit from a complicated circuit. You'll have to know AC and DC circuits both. So the DC circuits are pretty easy. The AC circuits will use inductors and capacitors in addition to resistors. You do have to know all of those. And then different types of measuring devices. So obviously like a voltmeter measures volts, an ammeter measures amps, and a wattmeter measures watts. So those are kind of self-explanatory. Three-phase power, so you'll need to know RMS values and power equations. And some load balancing. So let's look at the handbook. So if we go to here, you'll have to actually scroll down to find the electrical and computer engineering section. It will only ask you the most basic stuff here. So you do not need to know everything that the electrical engineers have to know if you're taking the other disciplines exam, or really any exam besides the electrical and computer. So electrostatic force. So we have two charges. We have 4 pi epsilon, which is the permittivity. And for air, you would use this value. And then times A, which is the unit vector. So that just shows the direction, essentially. And R is the distance between the charges, between the centers of the charges. So you get the force, then you can find the electric field value. You can find the work through the integral. But here is where it gets real. So voltage, so know the voltage and know how to get current. And then magnetic fields, probably won't ask you much about that. Induced voltage, probably not. Resistivity, this is an important one to know. So the resistivity here, that we use rho for that symbol, and it's not density here, it's resistivity. So this is electrical resistivity, which basically shows how likely or how unlikely something is to be a conductor. So if something has a high electrical resistivity, do not use it for a wire. It's not going to conduct well, but it will have a lot of resistance. So the resistance and resistivity of objects both change with temperature. So that's what these two equations tell us. Definitely know resistors in series or in parallel. So resistors add in series, they add 1 over in parallel. And the power is P equals IV. But obviously because V equals IR, then you can find it 3 different ways. So for Kirchhoff's voltage law, you'll need to know that going around the loop is going to be 0 change in voltage if you end at the same place you started, and that for a point or an intersection in a circuit, all of the currents sum to 0. So however much current is going into a node is the same amount of the current that's going out because the current's constantly flowing. There may be some questions on the Thevenin equivalent circuits. So whether you have a voltage source or a current source, be able to simplify to that particular form and find the load resistance or voltage. Capacitors and inductors are important to know. So you will have to know how to find the voltage in a capacitor and the voltage in an inductor using the capacitance and the inductance that are given. And you can use the exponentials there. Probably won't ask you too much about energy or inductance, reluctance, but capacitors and inductors in series and parallel. So the inductors add the same way resistors do. So they'll add 1 over in parallel and they'll add normally in series. Capacitors are the opposite. Capacitors add normally in parallel and they add 1 over in series. So the capacitor is different than the inductor and the resistor in that respect. Now for an AC circuit, you'll have a sinusoidal voltage wave. So you can get the average value using this formula. And for if you have full wave rectification, and for half wave rectification, it's literally just the peak amplitude of the sinusoid. The RMS value is probably something it will ask you about. So basically the RMS is going to be the maximum value divide by the square root of 2 if you have a full wave rectified. Phasor transforms, probably won't ask you too much about that, but impedance you do need to know. So you will have to be able to convert the impedance to the real plus the imaginary. So the real part here is the resistance component of the impedance, and the imaginary is the inductor and capacitor part of it. And that will slightly depend on the phase, which the phase is essentially the angle between the real and the imaginary. So you would make like real is one side of the triangle, imaginary is the other side of the triangle, it's a right triangle, and so you can find that angle. Okay, impedance and resistance are the main things to focus on here. There might be some questions on like, calculate the reactance for something else, but you probably won't have to use that a whole lot. Maximum power transfer theorem, you will get these from the Thevenin circuits. So for a DC versus an AC, just use the appropriate formula. And then for a transient, this is here, there probably will be questions on these. So whether you have an RL circuit, whether you have an RC circuit or an RLC, there is a different voltage formula for that. And it basically shows that it is a negative exponential. So you will start at one value and you will descend to another value just depending on what's going on. Okay, and then know these time constants. So the time constant being RC or L over R or RC on this one. And the time constant is what the amount of time that it takes to get to like 68%, I think, of its settling value. Resonance, another common complex power it might ask you about. So being able to calculate the power factor, you'll need to know this one. The VRMS, the IRMS, the cosine theta, and the power, and then you can calculate the power factor. And then in a three-phase system, you'll need to know the Y versus delta and how to calculate the balance and relationships. It may ask you about transformers. So the important thing to be able to do with the transformer is simplify it so that you know how the circuit on one side relates, the circuit past the transformer relates to the circuit before the transformer. And it's all going to be in this transformer ratio here. So the A is the transformer ratio, which is the N1 over the N2. And we can see here that this is proportional to N1 and the voltage on the front side are proportional in the same ratio, whereas the currents are proportional in the reverse direction. So you would have if N1 is bigger than N2, then you would have a bigger voltage, you would have a smaller current. And the impedance seen, which is essentially impedance is basically the resistance, capacitance, and inductance, would reflect across at a value proportional to the A squared. So if you have a high transformer ratio, then that's going to be extra, it's going to make it seem like an extra resistive circuit, the higher that ratio is. And that is probably, there is more stuff here, but probably this is as far as you would need to go for the other disciplines exam. So looking here at the module, there is this playlist here to go to that has an electrical engineering review, and this has a few different videos in it. So the first video is just a bunch of concept questions. So this will have a bunch of different multiple choice concept questions, all really good stuff to know, and you can get through that pretty quickly. And then the next videos in here show how to work out different problems on Ohm's law, Kirchhoff's law, AC versus DC, and three-phase power. So these are kind of all the basics of stuff that you would need to know for the electrical engineering section on the other disciplines exam.